Right. So, today we are beginning a new topic, that is data flow diagramming. Now, in data flow diagramming, what is happening? It is a tool by making use of which we can actually say data flow diagramming a tool to depict flow of data. So, what happens in the real life situation whenever we have let us say some sort of a system where we have various entities, and between the entities there is a flow of data. The diagram which depicts it is called a data flow diagram, right. So, that is what I said, that it is a tool to depict the flow of data and the transformations that it undergoes. So, there are two things, one is a flow of data and another is the what transformation the data undergoes. Now, see, for example, let us see, we have say we have a diagram like this, where we have the indents and we have the validated indents. So, if you look at this particular diagram, you will see that the indents are going through a process of validation, and we are having what is known as validated indents. All right, fine. You go and get some pens from the next room. So, you can see that the data that is coming from, now we can do one more thing, we can add here an entity. So, this entity let us say is a subsidiary. So, what is happening? We have the subsidiary, we have the indents, and we have, after validation, the validated indents. So, the entity is generating the data, that is our indent. This indent is coming to a process, that is validate, and the validation process is creating or transforming the indents to a new kind of thing called validated indents. All right. So, the data flow diagramming is a tool which helps us in generating these kind of transformations. Now, there is a fourth thing, in fact. That fourth thing is let us say when the indents are coming, we are also storing them somewhere. So, these are stored indents. These are stored indents. So, we can see here that we have some indents coming, the validation process transforms the indents to validated indents and also it puts it in a store, right. So, we can see therefore, that the data flow diagram uses 4 basic symbols. It uses 4 basic symbols. The first one is the data flow symbol, right, the data flow symbol. The second one is called a process symbol. That is shown in a circular manner. The third one is a data store symbol. And the fourth one is an external entity symbol. So, you see, just using 4 basic symbols, that of data flow, process, data store and external entity, we can develop any amount of complex diagrams, right. So, this is the beauty of this particular technique, that just using 4 basic symbols. Now, before that, let me give some basic idea that when we talk about data flow, essentially it has to be a real flow of data rather than a control flow of data. What is the difference between a flow of data and a control flow of data, or control flow? What is the difference? Control is? No. See, data flow can be one directional, two directional, or control flow also could be two directional. There is nothing like that. I think you are thinking in a different way. You have to think of a real system and think from that point of view.
It is with respect to achieving a particular objective control flow.
Okay, let us look at it this way. In the very first class, if you recall, I was talking about a physical flow and an information flow, if you are recalling, right, and there I was telling that every physical flow or physical system has got an associated information system, and in this particular lecture series we shall consider or concentrate on the information side and not on the physical side. Let us say what is happening in the physical process. The physical process is that we have some indents coming, some material requests are coming, right, and a purchase order is given, and actual material is coming. You see, when the actual material is coming, along with that a goods received note, you see that you have received the actual material and you are generating a GRN or a goods receipt note and sending it to the appropriate places to indicate that material has come, alright. So, a particular document that goes along with it, a GRN, is what we are calling as data flow. If it is simply a request for GRN, give me some GRN, alright, that is not a data flow, alright, or you give him some direction, process information. Suppose you are the manager, you are asking a clerk, please process purchase order. So, you can say a command instruction comes from the manager, right. We are not interested in those sort of things, we are simply interested in the flow of documents, what is really flowing, right. Many a time what happens, particularly in programming, you will see that when you are writing a program, you are sending from one program to another, some kind of control logic, that if maybe in the form of a flag. So, if flag equal to yes, the program will act in one manner, flag equal to no, program will act in another manner. That is actually a control signal that you are sending. What you are sending is a control signal in the form of a flag, but that is not a data. The data has to be a document, it has to have a structure in the sense that it has some attributes. Is it all right? So, that is a data. So, in that sense the indent is a data that is flowing, all right. If you are returning the indent, that is another kind of data that is flowing. Simply saying that some sort of we are sending a flag, if the flag is yes, then you process indent, if the flag is no, then you do not process indent, no, not that is not to be done. So, some of the interesting things about data flow diagrams, let us write them here. In short, we call what is known as DFDs. Should show the flow of data only and not control flow. This point already we have discussed. The second point, should not have decision structures. Decision structures, see, this is another thing. Many a time we are more interested in showing some sort of a decision structure. For example, let us try to draw some decision structure. So, look at this, that indents process instructions k equal to 1 reject, k equal to 0 accept, alright. So, as if a branching kind of thing is taking place, as if a bunching type of thing is taking place, that I think you know now what is a decision structure. A decision structure usually is like a triangle, and then you have some kind of information coming here, and yes, no, alright. So, if it is yes, you evaluate something, k equal to 0, yes, no, as if this process is nothing but that, no. So, we have our indents here, and if yes, then we accept, and no, then we reject. Look, so we have the indent coming here, then k equal to 0, yes, accept, no, reject. So, this is a decision structure. So, these kind of, now if you try to show these directly into a DFD and just put a process symbol here, call it validate or something, and then indents are coming, and then process instruction, and then say k equal to 0 accept, k equal to 1 reject. This is actually showing the decision structure. The idea is, this is what is not to be done. So, this is wrong, it should not be done, right, it should not be done. So, what should be done? If we do not do this, then what we should do? Let us put that also. See, this is a valid data flow diagram. We have the indents, we have the validate process, we have the validated indents, and we have the rejected indents. Actually, what is difference here is that the decision process is encircled or embedded, alright, into the process symbol. So, that is the idea. Now, how these indents are validated, what is the process, what is a validated indent, what is not a validated indent, what is a rejected indent. It may so happen in a particular run all indents are validated, none is rejected. So, these rejected indents, what does it mean? Does not mean anything, but even then essentially what we are writing is the inputs and all possible outputs of the process. Is it all right? Say, suppose you want to show the another as an another example, JEE selection process applicants See, I have just shown 3 categories: engineering selection, science selections, not selected, and you may go into hundreds of classifications: selected in mechanical engineering, selected in industrial engineering, like that, right. So, you can keep on having many number of subdivisions, whatever it may be, but this JE selection process, these applications, really not applicants, applicants, forms, etc. Actually, it should come from an entity called applicants. So, you can see that this JE selection process, now how this selection process bifurcates the applicants to various kinds of selections. So, you can see that this is a global view. So, not only decision, actually we should also mention that DFDs should not take into account and number 2 is very important, time, alright. So, DFDs should not take into account not only decision structure, but also time, alright. So, how time is coming, that is you can see that engineering selections, science selections or not selected, they are not actually happening in the same time. As you are applying, some of the people are not selected right in the beginning, they are not eligible. Some are screened out and the screening test, so they are not selected at that time, alright. Some are not selected in the main exams, alright. Some are not selected even after getting through IIT, I mean getting a rank, but not getting a seat, fine. So, you see that not selected is not happening in one time, it is happening at various times, fine. But if you want to make finer distinctions, you can always say further lines you can draw: not selected in mains, not selected in screening, not selected in application stage itself, etc., etc. So, the basic idea is this process symbol only shows that how it is happening is actually hidden, alright. We are only showing what document is coming, what document is going out, fine. So, this is how what we are basically achieving is that between the modules of the system, we are establishing that only there is a flow of data and nothing else, not the decision structure, not some sort of a command. The advantage that we achieve is they can actually be differentiated, they can be handled separately, alright. So, one process can be separately treated than another process, and you see this modularization is what we actually want. This modularization is actually what we want at the end of the day, so that if we have to develop a large software, we can divide the job into smaller fragments and give it to various people to do. Then let us see some of the rules about the DFDs which are important in the context. The rules are something like this. First of all, every every flow must involve a process. So, this basically has a far reaching meaning. What it means that if you are considering a flow, that flow should be between a process to a process, or a process to a data store, or a process to an entity, or entity to a process, data store to a process. Is it clear? Any other flow is illegal, should not be. Clear what it means? So, you cannot show something like this, but you may be tempted to do it. You may be tempted to do this kind of wrong structures. Anything else? So, you see what is happening here. This is an entity, this is the data store. So, if you show some data flow like from entity, let us say this entity is customer, alright. Think of an entity, external entity like customer, and think of a data store like customer's information, and assume the description says the customer stores his information in a data file. Okay. So, you are doing a purchase processing. Now, customer information is stored by customer himself, you are not doing anything, alright. So, how can you put it to a process? Because a process depicts your activity. If you are not doing anything, then why can't you show like this? The difficulty here is that if some data processing is going on or information processing is going on which does not include the present system, that has need not be shown, that is not our concern, alright, that is not our concern. What the data flow diagram depicts is only the processes, the flows and the data stores that are actually available in the current system and not outside the current system. Is it okay? So, that is what we should do. So, in that sense all these are wrong. Cannot have entity to data store, entity to entity, or data store to data store, data flow. Is it okay? Then second rule, very important. No crossing, dividing or joining of data flows. So, you cannot have something like this type, or all these are wrong, right. So, you cannot, two data flows should not cross. As such, this is not a mistake per se, but this is a very wrong way of drawing a diagram, right. It is not a mistake, it says crossing means you have placed your entities or things in such a manner that you just could not put them sufficiently properly, so that you could avoid the crossing of lines. But with a little bit of thinking you can always avoid any open diagram, you can always avoid the crossing of lines. Second is this one, the dividing of lines is absolutely wrong, absolutely wrong. If you have to, a line is actually getting divided, then there must be a process in between, alright. The process is doing something so that the line is actually getting bifurcated. Then the third one is two lines are joining, again the same logic should not be happening. Then finally, no flowchart symbols. You have all drawn flowcharts, like I have shown those decision structures and others kind of things. All these things should not be there at all. No flowchart symbols should be there, right. After this, there is another concept which is known as leveling of DFD. Actually, the leveling of DFD is based on a concept of human decision making which is known as 7 plus minus 2. What is 7 plus minus 2? Not 5 and 9, is 5 to 9, alright, 5 to 9. All numbers beginning from 5 up to 9 is known as 7 plus minus 2. Actually, the 7 plus minus 2 is a very important number. We will discuss about it later, while we shall discuss the humans as computing systems, how humans perform in information processing, because quite a bit of information is being processed by people themselves rather than by computer, and moment people does it, there are lots of errors and biases that comes in, and these errors and biases are very important element of information systems, right, because end of the day, however automation, computerization, whatever you do, you have to deal with people end of the day. So, these 7 plus minus 2 is actually limits to these are limits to human short term memory. In computer language, this is the RAM size of human brain, alright. This is the RAM size of human brain, 5 to 9, very less in fact, right. Nowadays, we talk about 512 MB RAMs, where 5 to 9 is nothing. But please remember, these 5 to 9 are not bits or bytes even. These 7 plus minus 2 are actually expressed in terms of what is known as chunks. So, human short term memory is expressed in terms of 7 plus minus 2. What is a chunk? You see, a chunk could be just a bit, it could be a byte, it could be a single number, or it could be a complete figure, alright. It could be a complete figure, entire page of a book, something like this. The point is how you associate that particular thing with yourself, alright. So, suppose a particular number is very familiar to you, suppose 439. What is this 439? Now, suppose it means nothing to you, then it is 3 chunks, alright. if 439 has no meaning to you, then it is 3 chunks. But if 439 is highly significant to you, suppose it is some interesting or important number for you, then it is only 1 chunk. Is it all right? So, that is why I said that this concept of chunk, it could be a complete figure also, all right. So, this is how. So, suppose I tell you a telephone number and I ask you, go to the next room and tell it to the person sitting there, all right. You can remember because you are keeping it in your mind for few minutes or even few seconds. But if I ask you this in the next class, what is the number I told you, you will not remember because you have kept it in your short term memory, all right. Now, whatever, that is another discussion, but what is important in the 7 plus minus 2 as a concept for leveling of DFD, because the short term memory size of human is so less, to effectively deliver or information or communicate information, we should see to it that at a time we are not delivering more than 5 to 9 things to humans. In other words, if you are drawing a diagram, the diagram should not be having too many symbols. Essentially, the data flow diagram is all about processes. So, one diagram should show not more than 5 to 9 processes, right. If you do this, then it will be easy for a person to comprehend. Is it all right? See, most of you, if you have given an examination, you must know that you should not start a difficult problem from page 1, because if you start from page 1, then you have to turn the page and you have to go to page 2, and if there are things which you have to keep referring, then you have to keep turning the page. You have to see it in page 1, again go back to page 2, again go back to page 1, which will not only increase the chance of making errors, but also will consume lot of time, all right. So, it is the same thing. Suppose you make a complicated diagram and then you have to understand this diagram, the discussions, details you are reading, then what will happen? You have to keep going back to the diagram if the diagram is too complicated. It is better, instead of putting everything in one diagram, why not we put a number of diagrams series by series and explode the diagram in steps. This is known as leveling of DFD. So, what is done here? Suppose we have a process here, all right. Now, these process actually having a transformation of A to B, transformation of A to B, all right, and also it generates C, stores D somewhere in a file, and also stores E. So, this is one complete view of the whole thing, all right. We have input A and output B, transformation that takes place. If you are rejecting, it could be C, it could be indents, validated indents and various stores, which example I have given. But in reality, the process is little more complicated than this. You see what is happening here, that A is coming, A is getting transformed to P1, P1 is the process which transforms A to F and generates C. Then F goes to a process P2 where you store it to a data store D and generate G, and in the process P3 you are storing E and finally obtaining B. Okay. Now we can always try to put them also, it may not be a circle. See, I have enclosed it. If I enclose it, then you see, try to use your imagination, you will find that we are seeing this diagram. In another words, if we put a lens on P, powerful lens, then we see lot of things happening inside. Is it clear what I am trying to say? Fine. Now similarly, we can go one step further. You see, now if A is your indents, C is the rejected indents, then what is happening here is, as you receive A, the first process, that is P11, is the obtain the indents, classify, put them together, alright. Then P12 scrutinize. After scrutinize, you reject C. Then these are the scrutinized and then further validate, consolidate. So you can see that likewise we can always go from stage wise into more and more details. Now see, this is the details of P1 only. Similarly, there will be details for P2, there will be details for P3. Now this is what is known as leveling of DFD. That means seeing more and more detail as we are going stage by stage. The first one, the topmost level, is usually called a context diagram. The second one is called top level data flow diagram, and the third one is called a detailed data flow diagram. Okay. So the context diagram, that is the first one. The context diagram is actually, it should show the entire system as one process. The beauty of the context diagram is that it should show the entire system as one process, and I have not drawn here, but it should also show the entities. It should also show the entities. So that means here C is actually going to these A only, etc. So you see that context diagram should show the entities, and from entities what information is flowing to the process, the overall process, and what transformation the information is going through, and also what are the various data stores which are used in the process. Clear? So, that is known as a context diagram. The top level data flow diagram on the other hand is a little more detailed, where you are showing individual processes and how things are happening there. Then we have the detailed data flow diagram where the individual processes are further labeled. This process is known as leveling of DFD. So, when we take up examples, we shall start seeing how to draw the context diagram, how to draw a top level data flow diagram, and how to draw detailed data flow diagram. Now, the question is where to stop. You can again have P11 and you can start drawing further detailed data flow diagram. Like that, you can keep on expanding the diagram to very minutest levels. The idea is the smallest process should be such which is reasonably easily can be translated to a single program. That is the level where we should stop. Where we should stop? If P11 is sufficiently small so as to be represented by a single program, right? What should be a single program? Approximately 50 lines of code. Approximately 50 lines of code. So, if we can get down to that level which can be implemented by a single program, we should not expand it further. Is it alright? So, that is the rule where we should stop. Fine. So, we stop here today. What we have covered today is the basic ideas of data flow diagram, and in the next class we shall take up some examples. Thank you.